Okay, here we go for part two. So I decided to work out these last two examples in case anybody wants to see them. If you feel like you've got this down, then feel free, skip ahead. So when I multiply these proportions, when I cross multiply, it will be negative 4, yes, that's a 4, times 2y plus 5 equals 6 times 7. So negative 4 times 2y is negative 8y. Negative 4 times 5 is negative 20. And 6 times 7 is 42. Add 20 to both sides. Negative 8y equals 62. Divide both sides by negative 8. And we get, if I remember right, 7.75. But let's double check that. 62 divided by negative 8 is negative 7.75. And for the last one, again, notice I did put my brackets around all of the pieces. So 7 times z plus 4 equals 9 times z minus 1. So that's 7z. 4 times 7 is 28. 9 times z. And 9 times negative 1. Subtract 7z from both sides. I get 28 equals 2z minus 5. Add 5 to both sides. 33 equals 2z. Divide both sides by 2. Z equals 16 and a half, I think. 16 and a half. Okay, so now the word problems. Probably the most important part. The whole key to the word problems are to make sure the proportions are consistent. So I'll kind of show you what I mean. So when we go through this word problem, Fernando conducted a survey of 50 students that drive 28 owned cars. If we have 75 students who drive, predict the number who own cars. So the red pieces have to stay together, and the blue pieces have to stay together. The things that own people who own cars have to stay together, and the people who drive have to stay together. So if we put some structure into here, if we're writing a proportion, we're writing two fractions that are equal to each other. So if I say, let's put the people who own cars on top and the people who just drive on the bottom. So we know that we had 28 who owned cars out of the 50 students who drove. So 28 owned cars and 50 drove. And then if 75 drive, how many of those 75 own cars? So the top two numbers, the x, the x and the 28 are both people who own cars. And the bottom two numbers, the 75 and the 50, are the total people who drive. So when you solve that, if I do the cross multiplication, we get 50x equals 28 times 75. Now, there are lots of ways to set up a proportion. You might have said, what if I want to put the people who own cars on the left and the people who drive on the right? So the people who own would be 28 out of the 50 that they talk to. And there are a total of 75 people who drive, and we want to know, set this up wrong, sorry. Ooh, try that again. 28 own out of the 50 who drive, and of the 75 who drive, how many own? So as you can see, it's easy to mix it up, but go back and double check yourself and say, okay, let's see, I have 28 who own, and this is what I'm trying to figure out is how many owned. And then I've got 50 who drive, and I have 75 who drive. So even though this proportion looks much different than the one on the left, when you cross multiply, you still get 28 times 75 equals 50 times x. And you could set it up a bunch of different ways. You could also do these upside down. So I could say that I have put people who drive on top, people who drive on top, and people who own on the bottom. So if I put my fraction out there, or my fraction bar so I can write my proportion, people who own on the bottom, drive on the top. So of the 50 who drove, we know that 28 actually own their cars. And of the 100 who, not 100, 75, I keep wanting to say that's 100. Of the 75 that drove, X owned their car. So again, we get 75 times 28 equals 50 times X. And we could flip this one upside down too and end up with X over 28 equals 75 over 50. This is drive. This is own. So there are lots of ways to set the proportions up. They give you the same answer no matter what you do. Okay, the last one. In an experiment, students netted butterflies, recorded the number with tags on their wings, and then released them. So the students netted 48 butterflies, and 3 were tagged. Predict the number of butterflies that would be tagged if there were 100 netted. So there are the two things that we're comparing, or we're comparing the tagged with the netted. So of the total of them they put in their net, how many have tags on them? So of that first group, we had 3 that had tags out of the 48 that was netted. And we want to know how many have tags of the 100 that they're going to net. And again, we could do this more ways. We could put tags on the top, netted, hard to write, netted on the bottom. So if I have 3 tags out of 48 netted and X tags out of 100 netted. And then if you solve that proportion, no matter which way you write it, you'll see 3 times 100 is 300 equals 48x. 3 times 100 is 300 equals 48x. So you're going to get the same thing no matter what. So there's really 4 main different ways that you can actually write this, because I could flip this one on the left upside down. X over 3 is 100 over 48. I could flip this one upside down. Those are kind of the 4 main parts that you get. So hopefully by now that we finished this, you have an understanding of basically what ratios are and the different ways that you can rate ratios. And then how you can use ratios to find angles, because you know that angles add up to 180, or to find lengths, to find perimeters if you're given perimeters. That our proportion is just the of 2 ratios. There it is, 2 ratios that are equal to each other, and how to solve proportions, and then how to write word problems for proportions. So hope everything goes well today. You can go ahead and get started on your homework. Whatever you don't finish in class, you can finish at home, and I will see you tomorrow.